Hello everyone and welcome back to Study Room. So this is our video lecture number 2 for the chapter 3, and in this video we are going to learn about the types of quadrilaterals. So let's see what are the types of quadrilaterals. The first one given is trapezium. So what is a trapezium? A trapezium is actually a quadrilateral with a pair of parallel sides. So a trapezium is such a quadrilateral that has a pair of parallel sides. You can see that here this arrow marks indicate the parallel lines. So AB and CD, these both lines are parallel to each other. Since we have a pair of parallel sides in this figure, so we can say that this figure is actually that of a trapezium, because trapezium is a quadrilateral that has a pair of parallel sides and AB is parallel to, here AB, we can say AB is parallel to CD here. So it is a trapezium. You can see that here we have given some figures and all of these are trapezium. These four figures are going to be trapezium because we are having a pair of parallel sides in each of them. While these are not trapezium. Why? Because in these we are not having pairs of parallel sides. You can see we are not having pairs of parallel sides. Now the next kind of quadrilateral is that kite. So what is a kite? A kite is actually a special type of quadrilateral that is having four sides, and there are exactly two distinct consecutive pair of sides of equal length. So the consecutive sides are going to be of equal length. You can see that this side is equal to this side while this side is equal to this side. So such a quadrilateral is known as a kite. It is a special type of quadrilateral that is having four sides. So it has four sides, but the consecutive pairs of sides will be of equal length. These are of equal length and these two are of equal length. The diagonals are perpendicular to one another and one of the diagonals bisects the other. So if we'll find the diagonals, one diagonal will be this, other is going to be this. So these diagonals are perpendicular to one another. They make 90 degrees with each other and one of the diagonals bisects the another. You can see that this diagonal is actually bisecting this one. These both parts are going to be equal. This is a kite. These are all the points of a quadrilateral, that is a kite. So some of the examples of kite can be seen here. You can see that all these three are kites because here the consecutive pair of sides are of equal length. These two equal, these two are equal, here these two are equal and these two are equal. While in this, these two and these two are equal to one another. While these are not kite. These are not kite because this one is not having four sides. This has four sides, but the consecutive sides are not equal, while the opposite sides are equal in this. And similarly, this not equal. Consecutive sides should be equal for a quadrilateral to be a kite. Next one is that parallelogram. So parallelogram is a quadrilateral whose opposite sides are parallel. So when a quadrilateral has opposite sides parallel to each other, then such a quadrilateral is said to be a parallelogram. It is a very important quadrilateral, a parallelogram, where the opposite sides are parallel to each other. So we can say that here AB is parallel to CD, B is parallel to CD, and here this AC is parallel to BD. AC is parallel to BD. Elements of a parallelogram. So there are four sides and four angles in a parallelogram, and in the parallelogram ABCD, the sides AB and CD are opposite sides, AB and CD are opposite sides, and the sides AB and BD are adjacent sides. Similarly, we can say that angle ACD, I mean this angle, and angle ABD, this angle, are opposite angles, and angle ACD, this angle, and angle BDC, these are adjacent angles. These are known as opposite angles, while these are known as adjacent angles, together, the angles that are together. This is a parallelogram and its elements. Now we are going to study about the properties of a parallelogram. So what are the properties? The first property given to us is that the opposite sides of a parallelogram are of equal length. So always the opposite sides of a parallelogram are going to be equal. That is, here in this ABCD parallelogram, AB and CD will be of equal length, while AC and BD will be of equal length. So let's see the proof of this property. BC is the diagonal of parallelogram ABCD, therefore this ABCD parallelogram has BC as a diagonal. Therefore angle 1 is going to be equal to angle 2 and angle 3 is going to be equal to angle 4. These two angles are going to be equal to each other, while these two angles will be equal to each other. Why is that so? Because these are the alternate interior angles, right? These are the alternate interior angles and that is why they are equal. 1 is equal to 2 and angle 3 is equal to angle 4. And BC is common, right? BC is common in both these triangles. In angle ABC and in angle BCD, BC is common. And these angles are equal to these angles. 1 is equal to 2 and 3 is equal to 4 angles. Therefore, we can say that angle ABC is congruent to angle DBC by which property? It is by angle side angle property. Because angle 1 was equal to angle 2, the side BC was common and angle 3 was equal to angle 4. Therefore, we say that triangle ABC is congruent to triangle DBC by ASA property. Hence, we can say that AB side is equal to CD side and similarly AC side is equal to BD side. So, here we have proved that the opposite sides of a parallelogram are always going to be of equal length. You need to remember this property. And we are just going to use this property only in this example. Example number 3, you can see that we need to find the perimeter of this parallelogram PQRS, right? So perimeter, what does perimeter means? So perimeter is actually the sum of all sides. We are given the length of side PQ and QS. If we are able to find the length of side RS and RP, then we can be able to find the perimeter because we will add all these to get the perimeter of this parallelogram. So, just from the previous property that the opposite sides of a parallelogram are of equal length, we can say, what can we say? We can say that PQ is equal to RS and SQ is equal to RP. This side will be equal to this side, that is this also will be 12 centimeter, while this side is going to be this side, that is this also will be 7 centimeter. This will be 12 centimeter while this will be 7 centimeter. So the perimeter, this perimeter of this given parallelogram PQRS is going to be 12 plus 12 plus 7 plus 7, that is equal to 12 plus 12 is 24, 7 plus 7 is 14. You can do it in the rough side and it will be 38. So it is 38 centimeter. What is the perimeter of this parallelogram PQRS? It is 38 centimeters. Next, we have another property of parallelogram. The second property states that the opposite angles of a parallelogram are of equal measure. So previously it was the opposite sides that were equal. Now we are talking about the opposite angles of a parallelogram. So opposite angles of a parallelogram are of equal measure. We need to prove in this parallelogram ABCD, angle A is going to be equal to angle D while angle C is going to be equal to angle B. This is what we have to prove because this is what the property says. So the proof is like, we know that BC is the diagonal of this parallelogram, right? BC is the diagonal of this whole parallelogram. ABCD, therefore angle 1 will be equal to angle 2, angle 3 will be equal to angle 4. These are alternate, just as we saw it in the previous example that these two are alternate angles, so these will be equal. These two are alternate interior angles, so these two will be equal. And BC we have common. Therefore, we can again say that ABC, this ABC triangle, again we are going to prove this congruent, these two triangles congruent, ABC congruent to triangle DBC by again the same angle side angle property, angle side angle rule. Hence we can say that this angle is equal to this angle, A is equal to D, and similarly if we take this diagonal AD, then again if we prove these two triangles congruent, then we can say that angle C equals to angle B. So this is how we prove that the opposite angles of a parallelogram are of equal measure. Now we are going to use that property only. In this example number 4, we are given BEST is a parallelogram. This BEST is a parallelogram that is given to us. We need to find the values of angle X, Y and Z. So X is this angle, Y is this angle and Z is this angle. We can see that angle B is opposite to angle X. So these two angles from this property only, that the opposite angles of a parallelogram are of equal measure, we can say that angle X is going to be 100 degree, because these are two opposite angles and the two opposite angles of a parallelogram are of equal measure. So X is 100 degree. Now you can see that X angle is going to be equal to this angle, right? These two angles are going to be, I'll write it, X is going to be equal to Y angle. Why? Because these are the corresponding angles. These are the opposite angles, these are corresponding angles. Therefore, these two angles will be equal. We can say that since X was 100 degree, we can say that angle Y is also 100 degree. Y is coming to be 100 degree, X is coming to be 100 degree. We need to find now angle Z. So we can see that, here you can see that Z and Y form a linear pair. Z plus Y form a linear pair. What does that mean? Linear pair, that means that the sum of these two angles is going to be 180 degree. So we need to find angle Z. We have angle Y as 100. This is equal to 180 degree. So our angle Z is going to be 180 minus 100, that is 80 degree. So we have found out angle Z, we have found out angle Y, and we have found out angle X. So that is what we had to find out here in this example, the values of X, Y and Z, and these are 100, 100 and 80 degree respectively. Another property of a parallelogram is that the adjacent angles in a parallelogram are supplementary. So what is it given? It's given to us that the adjacent angles, the angles that are not opposite, that are like together to each other, right? So the adjacent angles in a parallelogram are supplementary, What does that mean? That their sum is going to be 180 degree. Adjacent angles are supplementary, AC, or we can say AB, or with B and D, or D and C. These are going to be supplementary. How do we prove it? We know that AB is parallel to CD, right? AB is going to be parallel to CD, and AC is the transversal, right? AC. So these two lines are parallel, and this is, we can say, the transverse, right? Transversal line. We know that the interior angles on the same side of a transversal are supplementary. Yes, we know that. We have already studied about it, that the interior angles are on the same side. Yes, this is coming on the same side, on the right side of this transverse AC, the right side of transverse, and our interior angle. The interior angles on the same side of a transversal are supplementary. Their sum is 180 degree. We can say therefore that angle A plus angle C is going to be equal to 180 degree. These are, and what are these? These are the adjacent angles of this parallelogram ABCD. Therefore, we have proved that adjacent angles of a parallelogram are supplementary. So this was the third property that we have proved for a parallelogram, that the adjacent angles in a parallelogram are supplementary, that is, their sum is equal to 180 degree. See this example number 5. In a parallelogram given to us, that is ring RING is a parallelogram that is given to us. The measure of angle R is given to be 70 degree. We need to find all the other angles. We know that since R is 70 degree, and this angle will be just from the previous property that the adjacent angles in a parallelogram are supplementary. We can say, by using this property, we can say that angle R, measure of angle R plus measure of this angle G is going to be equal to what? 180 degree, right? Because these are supplementary. You can write in the bracket that these are supplementary. R is given to be 70 degree. We need to find this. We need to find this, right? Sum is 180 degree. This will come to be 180 minus 70, that is 110. So this we have found out, it is 110. Now we can easily do it. These are opposite angles. This will be again 110 because the property that we did earlier, that the opposite angles of a parallelogram are of equal measure. So we can say that since measure of angle G is equal to measure of angle I, this I, opposite angle, therefore measure of angle I is also going to be 110 degree. Now you can see that this angle is opposite to this angle. Again we can use the property that the measure of the equal angles of a parallelogram are equal. They are of equal measure. Therefore this m measure of angle N is going to be equal to the measure of angle R, that is 70 degree. So this is 70, this is 110, and this is also 110, and we have found out all the other three angles of this parallelogram ring Ri and G. We just need to use the properties. We have one more property, and that property states that the diagonals of a parallelogram bisect each other at the point of their intersection, right? So we know that AD here and BC here, these two are the diagonals of this parallelogram ABCD. These two are going to actually bisect each other at the point O is their point of intersection. So here these two diagonals are actually bisecting each other. This length AO is going to be equal to this length OD, and this length OC is going to be equal to this length OB. So let's see the proof of this property. Now we have triangle COD and AOB. COD, this triangle, and AOB, this triangle. We have these two triangles, and we can say that angle 1 equals to angle 2. Again alternate interior angles. AB equals to CD because these are the opposite sides of parallelogram. Therefore, these and angle 3 also equals to angle 4. Not only angle 1 equal to angle 2, but angle 3 is also equal to angle 4. Again the alternate interior angle, these two are the alternate interior angles. So again by the ASA, we can say that these two triangles that we had taken, triangle COD is congruent to triangle AOB. Therefore, we can say that AO equals to OD and CO equals to OB. This is how we have proved this property. This proves that diagonals bisect at O. This point of intersection is O. Therefore, these diagonals bisect each other at this point of intersection, that is O. We have this example number 6. We need to use this property for the solution of this example. HELP is a parallelogram here. HELP is a parallelogram that is given to us. Given that lengths are in centimeters and also OE equals to 4 centimeter. We are given OE to be 4 centimeter and HL is 5 more than PE. This HL diagonal is given to be 5 more than PE. So whatever our PE is, HL is going to be PE plus this HL is given to be, HL is 5 more than PE. Whatever our PE is, it will be 5 centimeters more than PE, right? It will be 5 centimeters more than PE. Given OE is equal to 4 centimeters. If OE is 4, we know that OP will also be equal to 4. Why? Because this is the diagonal, this is the other diagonal, they are intersecting each other at O, they will be bisecting each other. This is also going to be 4 centimeters. So we have OP also equal to 4 centimeter. Therefore, our whole PE is going to be 4 plus 4, OP plus OE, that is 8 centimeter. Now, since PE is 8 centimeter, we are given that HL is, this is 5, right? HL is nothing but PE plus 5, that is 8 plus 5, and that is 13 centimeter, right? So P is 8, HL we have got it to be 13 centimeter. We finally need to find OH. In our example, we need to find OH. What will be our OH? OH will be nothing but since OH equals to OL, because this diagonal is bisecting this diagonal, therefore OH is going to be equal to OL. That is equal to half of this whole HL, half of our HL, that is equal to half of 13 centimeter, that is nothing but 6.5 centimeters. So we have found out the length of OH, and that is 6.5 centimeter. This is what we had to find. We used which property? We used this property, that the diagonals, see, we used which property? We used the property that the diagonals of a parallelogram, they bisect each other at the point of intersection. So this is exactly what we used here, and we found out the answer. We have found out the answer, that is the length of OH we have found out. So this was all that we had to learn in this video lecture, the properties related to parallelogram. In the next video, we are going to learn about the types of parallelogram. So let's meet in the next video. We'll connect in the next video. Till then, have a good day. Bye bye. Take care.